Jai Jirendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the ninth question of the problem solving series, which is based on array. So this question has been asked in multiple companies like Microsoft, Amazon, Oyo, Flipkart, DSO, and a lot of companies. This is a very popular question. So let's begin. The difficulty level for this question is medium. Largest sum contiguous subarray Kadane's algorithm. So we know what is subarray. It is the contiguous elements of an array, and we need to return the largest sum of the subarray possible. So if we see over here in the second example, we'll start with the second example. So 4, 2, minus 3, 7 and minus 4. Which subarray we should take which will give us the largest sum? For example, if we take this subarray, what is the largest sum? 4 plus 2, 6. But if we take this minus 3, then our sum becomes 3, which is not the bigger subarray than this. But if we include 7, then it becomes 10. And if we include minus 4, it again reduces. So what is the largest possible sum giving subarray is this. 4, 2, minus 3 and 7. So our answer will be 10. Now coming back to this question, this example. In this example, what would be the largest subarray? Largest sum of the subarray. So minus 2, minus 3 is minus 5. So this is smaller than this subarray. And again minus 5 plus 4 is 1, which is bigger than the other subarray, current subarray. So this is 1, and if we include this, then again it becomes 0. Minus 2, minus 3, minus 5 plus 4 is minus 1, and minus 5 plus 4 is minus 1, and minus 1 becomes minus 2. Minus 2 is smaller again, minus 2 becomes 4, minus 4. So if we are taking the negative element, then we can see that the sum is becoming negative. So if I don't take this and I start with 4, then there is a chance that our subarray size sum will be more. So let's exclude this. So if I take it from here, 4 minus 1 is 3. So still we will take this subarray as sum only, and again 3 minus 2 is 1, which is again smaller than 4. Our max is 4 right now. But if we include this 1, then what is the sum? 4 minus 1, 3, 3 minus 2 is 1, 1 plus 1 is 2, which is still less than 4. But if we include this 5, then what is the sum? 1 plus 1, 2 plus 5, 7, which is greater than this 4. So if we take this, then we have the largest subarray right now with max sum. And if we include minus, then again it becomes negative. So what is our solution here? This is our solution. So 4 minus 1 3 minus 2 1 plus 1 2 plus 5 7. So we will be returning 7. So how do we solve this? While solving the answer only, we can think about the intuition. Firstly, we'll discuss about the brute force approach. The brute force approach for this kind of subarray problem is very clear. We can find all the subarray and we can see which subarray has the maximum sum, and we can return it. How do we do that? We can do it by nested loops. We can start our loop from here, and first loop, and we will start from j is equal to I plus 1 to n, and we will take the sum from here to here, here to here, everything will calculate, and we'll have whatever the sum, whenever the sum is the maximum, we'll return it as a max, and then again this will come over here. In this way we can take all the subarray, and the time will come, I will be over here and j will be over here, and this sum will be the maximum, and we will return that after, and all the other subarrays we won't cross this. So what will be the time complexity for this nested loops? The time complexity would be order of n square for brute force. This brute force approach, nested loops. Now what would be the optimal way of solving this? We just discussed the optimal way while we tried to find out the solution for this example. What is the intuition? When we were discussing this example, I was taking these are negative, so let's not include, because whenever we include a negative number, the sum will decrease, right? So if we start excluding negative number, then there is a chance that our subarray, we can take a subarray with maximum sum. But then again, if we excluded this 2 over here, but we did include this, and we kept on having a counter where we stored the whatever the maximum sum we are getting. So why did we include this? Because if we don't include this, we can't have this maximum sum. If suppose by chance this minus 2 was minus 3, then our sum would have become negative. This part would have been negative. Minus 4 say. Then this part would have been negative. So if this part would have been negative, if you would have included this, then 1, 5, there is no point of including this because this is decreasing its value. So first thing is we are ignoring the negative elements and we are trying to take the negative elements only when it doesn't make the total sum lesser than 0. So these are the two things. So these are the two intuitions that have been used in Kadane's algorithm to solve this in order of n. So what are the two things that we will be checking? We'll have a counter where we'll be storing the maximum sum at a particular index. We'll be checking, and we'll have a check whether that sum was maximum previously or not. So we'll have two variables. One may be sum where we'll be getting the sum at particular index, and one will have a max which will be taking say maxi, will be taking max of maxi comma sum, right? And if while taking the sum we see that if the sum is negative, sum is becoming negative, we will exclude this, we will not take this. For example, minus 2 we have not taken it, minus 3 we have not taken it, right? Then when it came to 4, then we just started it from 4 because no point of taking this. So the second thing is whenever the sum becomes 0, when we take the sum would be sum plus ai. If we are taking this ai, if this becomes negative, then we will make the sum as 0. So in this way, we will be able to solve this in order of n. So let me write the pseudocode for this. It's very simple. So we'll have int of maxi comma sum equal to 0. Maxi is int min. Let it be int min. And then we will traverse the array for I to 0 is equal to 0 to n minus 1. And what we'll do is we will have sum is equal to sum plus a of I, right? And maxi would be max of maxi comma sum. And if sum becomes less than 0, then we will make the sum as 0. Simple. And we will return maxi. Right? Let's run this pseudocode for this example again once more. So here we have assigned it as a minimum value and the sum is 0. It comes over here. Sum is minus 2. Is minus 2 lesser than the maxi current value? So yes. So the maxi value becomes minus 2. Right? Maxi becomes minus 2. Maxi becomes minus 2. And now since minus 2 is less than 0, then sum is 0. Sum is 0, okay, in the first iteration. In second iteration, what will happen? sum is 0 right now, minus 3 comes. So 0 plus minus 3 is minus 3. What is bigger, minus 2 or minus 3? Minus 2 is only bigger. So still maxi would be minus 2 only, and the sum would again change to 0 because minus 3 is less than 0. So sum is 0 and maxi is minus 2 till here also. Now 4 comes, sum is equal to 0, 0 plus 4. Now sum becomes 4. And what happens to maxi? Maxi becomes max of minus 2 and 4, that is 4. Okay. And now what is sum? Sum is sum less than 0? No, it's not less than 0. So current value of sum is 4. Now minus 1 comes. So what is the value of sum? Sum becomes 4 minus 1, 3. And maxi is 4, 3. So maxi is still 4 because 4 is bigger than 3. So maxi is 4 now. And what is sum? Sum is equal to 3. Right? And sum is not less than 0. Sum will be 3. Minus 2 comes. 3 minus 2 is 1. And maxi is 4, 1. Maxi is 4 only. And sum becomes 1. And again sum 1 plus 1. So sum becomes 2. Maxi is still 4. 2 plus 5, 7. Max sum becomes 7. And then what is the maxi value? 4. So maxi will become, choose this now. So maxi will also become 7. Sum will be 7. And now 7 minus 3, 4. What is the maxi value? What maxi will choose? 7 or 4? Maxi will choose 7. So in the final round, maxi will be 7 and sum will be 4, and we will be returning 7. So this Kadane's algorithm is a kind of this algorithm is a kind of greedy algorithm also and dynamic programming algorithm also. We will discuss greedy and dynamic when we solve the questions of both of them. But just to give a hint, like in greedy algorithm, we choose the greedy approach, the approach which gives us the maximum result. So here, whenever we get the negative value, so we exclude those negative things. So in this way, we are kind of making a greedy approach to the solution. And in dynamic programming, one part is that we make choices whenever we whenever there is a recursion and we want to optimize that recursion, the continuous calculation. So we choose the best possible path before doing that. So in the best possible path, we are not choosing this. We are choosing this maximum. We always have a choice to choose either maxi or sum. So we are choosing the best possible path. So in this way, Kadane algorithm is a combination of greedy and dynamic. So in this Kadane algorithm is very important, and the time complexity of this is order of n, the space complexity will be order of 1 because we have not taken any extra space. And so I think the solution is clear. The link to the question has been given in the description. Please try it yourself, and then let's discuss the code walkthrough. Here is the code walkthrough of the 9th question, maximum subarray. Implemented the Kadane as algorithm. So we have taken the maximum sum as int main, and we are traversing the array, and we are finding the maximum sum, and we are discarding if the sum goes 0. We are comparing it with maxi every time, and I've already explained the solutions in the pseudocode. Let's run it. So it's working fine, and let's submit this. So it has worked fine. Let me know in the comment section how was the explanation of this question, and I'll see you in my next video where I'll be explaining the 10th question that will also be based on arrays. And Jai Janendra.